Hi there, this is Jacob Nash, Algebra Lessons, and this is Unit 0, Lesson 5, on Solving Equations Review. So, we did expressions in Lessons 3 and 4, but now we have equations, so that means they have a equal sign on them. Now, there are certain cases in which answers will be different. Sometimes there's no solution possible. We'll look at a case like that. But let's just think of a small equation that's easy. Probably a pre-algebra equation that you might have learned before you even took Algebra 1. Like I've said before, this is meant for Algebra 2, these videos. So, Algebra 1 people, you should probably find someone else. So, this is just a basic equation. Do you know what to do? So, when we're finding a variable, we need to figure out what it equals. How can we figure out what x equals that would make this statement true? What plus 3 equals 8, basically, is what this is saying. Well, off the top of your head, you can already say 5, hopefully. That would make it true, because 5 plus 3 is 8. And that's an easy way to think about it, but really, how we could do that, we just have to get x by itself. So anything that's with x needs to go on the other side of the equation. And the only way to get it onto the other side of the equation is to make it cancel out with each other. So what can you do to it that would make it equal 0? If you subtract 3 from 3, then you get 0. So they cancel out. But we have to subtract 3 on both sides. So we get x, and it's by itself, so 8 minus 3 equals 5. That's a very basic one. X had no coefficient. And coefficient is the number that's right beside x or any other variable. It's like right here, and you have to multiply those together. And if there's none, then it really just means it's 1. So now let's look at one where there is a coefficient. How about 2, let's use a different letter, J, equals 18. Now what do? We need to get J by itself, so we have to make 2 turn into 0 or nothing, so it's gone. What's the opposite of multiplying? It's dividing. So we divide by 2, and J equals 9. That's simple. So those are very simple equations. But in Algebra 2 and some in Algebra 1, you have more complicated ones. So let's make up one. I'm trying to think of a good example. So how about 3x plus 4, and let's just say that there's a 5 here, equals 18. Okay, we have to distribute like we've talked about. So 5 times 3 is 15x, or 5 times 3x, sorry. And then 5 times 4 is 20, equals 18. The first thing we need to do is get the 20 gone. We can do that by subtracting 20 on both sides. And then we get 15x equals negative 2. Now we need to divide by 15 on both sides because that's the opposite of multiplying. And there's multiplying right there. 15 times x is really what that means. And then we get x equals negative 2/15. Sometimes you have to have it in decimals, so that would be 0.13, negative 0.13 repeating. So that's the answer. But in this case, x, there was only one x, and you didn't have to combine any like terms or get both x's on the same size. In some cases, you'll have to do that, as you may remember, or you should remember, I guess. So, here's an example. 4x plus, let's just do a little bit bigger numbers this time. 52 equals 42x minus 33. there's x's on both sides. Before you do anything, you want to get the x's on the same side. You have two options. You can make the 4x go to the 42x side, or make the 42x go to the 4x side. Usually you want the smaller number to go to the bigger number side, just so that negatives don't get confusing. So let's subtract 4x from both sides, and we get 52 equals 38x minus 33. To get 33 gone, we add 33. And then we get, let's just switch sides, 38x equals 85. And then we divide by 38, and we're going to get a very strange number, because I just made this up off the top of my head. We get 2.24 approximately. But let's do a fraction. On your graphing calculator that you may have, if you push the math button, which is below the second and alpha buttons, and then you push enter or 1, and then enter again, it changes it to a fraction. But we still get this same fraction because 85 over 38 cannot be simplified. So you could just give this answer or this answer depending on what you need to do. So there we go, that's expressions. Oh, what the heck did I do? That thing's up there now? Okay. Didn't even know that could happen. On my videos for JNGL, I used to use something called Wix, or Wixie actually, and that thing got messed up, and it's not the same anymore. And then and then for engineering, I would use my phone app at first, and that didn't work good. And then this tablet sometimes would mute, or this iPad. And then what I'm going to do is I'm going to use iPad for working out problems, which is most videos. But if there's ever an instructional one where I don't need to really write out everything and there's like vocab words or equations, then I'll do a slideshow for those lessons. But that's not as often. So now let's look at a situation where there might be no solution. Let's see here. Here's one example. We need to find x. Here's what we do. Well, we need to distribute. Luckily, there's only one thing to distribute for. Or 2. So, 7 times 5x is 35x. And 5 times 7x is also 35x. We need to get x on a side by itself. Let's just do this. Plus 0. We can do that. So that's easier. We need to subtract 35x from both sides. And then we get 0 equals, well, it cancels out on both sides. So we just get 0 equals 0. And in this case, we didn't even find out what x was. So there's no solution. That's just messed up. There's also situations where 0 does equal 0, but sometimes there's weird things where it's not even true. So here's another example. Let's say 6 times 4x plus 12 equals 4 times 6x minus 7. So we distribute 24x plus 72. And then we get 24x minus 28. So basically, if you ever see that x is the same thing on both sides, it's going to be no solution. So if we need to get x on the same side, then we subtract. They both cancel out, and we get 72 equals negative 28. What the heck? That's not true. So that's another no solution thing, but that time it's not even true. So now, a final thing that you might have to do in solving equations is where you're not even really finding a certain number, but you're just rearranging equations. So here's what I mean by that. In engineering, there is something called thermodynamics, and it doesn't matter that you might not know what that is, but there's one equation that I just randomly thought of that's Q equals MC delta T. Yes, that's uppercase. Your teacher will slap you in the face. That's a song. So, anyways, there's no numbers here, but let's say in this context we wanted to know what C was. How could we rearrange it so that C is by itself? We need to divide. We need to divide each thing because they're all being multiplied. And just as a heads up, delta, that triangle thing, means change in and it's with this. So that's one thing. So you can't separate those two. So let's first divide that. Divide delta T on both sides. So now we have MC equals Q divided by delta T. We can divide by M, and then we get C equals Q divided by delta Tm. We just rearranged that thermodynamics equation to find C, which that's actually kind of pointless because C is a constant in thermodynamics, and you're always given that, so you never would have to find it. But anyways, that's not the point. Let's look at a random example, but it doesn't have to be an equation. So let's just think of something random, all right? Let's say we have an equation that says P equals JL over NA. I don't know, you see JNAL, whatever. And you want to find J. How can we do that? Well, this time it's different. So, before we could just divide, but what do we do about the NA? Well, whenever there's something on the denominator, you can multiply it by what's on the other side to get the right answer. Just think about it. So, 4 equals 8 divided by 2. How can we rearrange it so that we say something about 8? Well, 4 times 2. So that's what I mean by that. So we multiply P times N. So now we have Pn equals JL over A. And then we can multiply again. P and A equals JL. Really over 1, but we don't need to say that. Now we can just divide by L. So J equals PNA over L in this situation. Let's do one more before the video ends. So now we have this equation. So W equals XZ over AB, and let's make that all squared. This is more complicated. So here's what we do. Well, the first thing that we can do is just take the square root. Let's just knock that dumb thing out of there. That's complicated. So we take the square root, and that makes these things cancel. So we have the square root of W equals XZ over AB. Now we multiply by AB, remember, because that's on the denominator. So square root of WAB equals XZ. Now, I forgot to say what we were finding. Let's say we're finding Z. We divide by X, and Z equals the square root of WAB over X. Ooh, that's kind of crazy, but that's what we have to do. So you see, it's not really that complicated. This is some Algebra 1 review, and hopefully this makes sense. If not, please leave a comment. But that will be it for this video, and I'll see you on the next one. Thanks for watching.